All right, in this lesson and the next, we're going to talk about how to solve simple trigonometric equations. So to get into that, we need to review some of the important topics we've talked about the unit circle the last few lessons. Now, again, the last few lessons, the homework wasn't too heavy, but it's really important conceptual stuff. And if you have the time, or even going into next year, I would encourage you to review these videos or discuss these things with your teacher next year. So remember, there's two ways. There's more than two, but the two biggest common, most popular ways of measuring is radians, which is to measure the length of the arc going around the outside of the circle, right? So when we do a radian measure, that's just a regular real number. I know we call it a radian because it comes from the radius, right? And generally our radius starts at equal to 1, right? And we can use whatever we want. Sometimes we use t for it, right? Or, you know, it doesn't have to be t. That's very common. But a radian, okay? Now, when you hear people talk about the winding function, it's the same thing. The idea of as you wind around the circle and you end at that terminal point, right? What is the length of that piece of string that we've wound around? So I haven't used the phrase winding function a lot, but it's the exact same thing, okay? Now, there's another way of measuring, right, which is an angle. And angles are measured in degrees. And a lot of times we use theta, Greek letters for that, or other Greek letters. Now remember, they seem similar, but this isn't a length. An angle is a measure of rotation. As I rotate an arm from here to here, how much did I rotate it? And we break a circle into generally 360 degrees, right? There's also gradients, which you can measure, which is a different method. It goes back to French. I won't get into that right now, okay? Back to French. All right, so we'll stick to what's important here. So for solving right now, we're going to do everything in degrees right now while we're solving. We could do with radians too, but we're going to stick with degrees for now, okay? So remember, as we measure and we end up at that terminal point, right? That end point, there it is. What are the definitions of cos and sine? Remember, cos of the angle, again, we're just going to use angles for now, degrees, right? Cos of that angle, right, will give me the x-coordinate. And if I punch in sine of that angle, it'll give me the y-coordinate. So by typing in, let's just say this was, 30 degrees or something, right? So I could type in cos of 30 degrees and it'll give me the x-coordinate, and sine of 30 degrees and it'll give me the y-coordinate, right? All right, so we could find those angles. And that's the birth of cos and sine. Sine, again, coming from Latin, and it's a real long way. If you ever are bored and want to look up why we use sine, it's almost ridiculous where it comes from through so many translations. It's really lost in translation, its meaning. It's not like it directly relates to one thing. It's kind of wacky. And cosine, just meaning the complement, the co, right? Co is another Latin structure, when you have a couple, or co meaning right together, right? So the component, the coupled version of sine, okay? All right, so x and y are figured out by sine or cos and sine, right? So that's what they are. So we got to keep that in mind. Now, obviously, we can use that to solve triangles, and we're going to talk more about triangles coming up later, right? And this is where it all comes from. This is why we use sine and cos, because you can draw a right angle triangle in our unit circle, right? It doesn't come from anything else. This is where it all comes from, is this triangle that we draw in our unit circle. And I keep saying that over and over again because it's a really, really important concept to understand where cos and sine and tan and all that come from. But sine and cos are the main two, right? Now, what about tan? Remember what tan is? Tan is essentially just slope, and it comes from another Latin word which is a little easier to trace back because it comes from the word tangere, which means to touch, and when you're finding the slope of something at that point where it just touches something. But we'll get into that more graphically later. Tan, the main thing we remember, is slope. Well, what's slope? Slope is rise divided by run, right? Isn't that what slope is? Rise over run. Well, what's your rise? It's y. And what's your y? Sine. So tan is just your y, which is sine of the angle, the y-coordinate, the rise, divided by the run, the x-coordinate, which is cos. Okay, so that's what tan is. So tan is the slope. All right, so really important. Now, then we had our reciprocal functions. We won't worry too much about them right now until we start doing some examples, okay? But those are the three big ones. Sine and cos are the big ones, and tan is what you get when you divide sine by cos, which gives you the slope. And that would be the slope of this line segment right here, right? What is the slope of that line, right? The rise and run, okay? Now, before we can start solving, we got to talk about where are sine, cos, and tan positive and negative, right? So there's this thing called the cast rule, which is one way of memorizing and learning it. I don't personally use it a lot, but it comes up so often, it would be silly of me not to talk about and discuss with you. And it's really simple. There's a couple different ways of looking at it is what I'm trying to say. So let's imagine our unit circle again. I'm going to draw a quick circle here. Okay, so I've drawn a circle, right? Now, let's think about where's sine positive? Let's start with sine, right? Where is sine positive? So sine is your y-coordinates. So where are your y-coordinates normally positive, right? Well, let's first label actually maybe our quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? Okay, so where are your y-coordinates positive? They're positive up here, right? So remember, let's just do it a little more here, right? Your y-coordinates, I'm going to draw like a point that could be in each quadrant, right? And this is pretty simple stuff. This is going back to grade 9, maybe in elementary school if you were doing graphing back then, right? Where your y-coordinates positive? They're positive here and here. So that's where sine is positive, right? Sine is the y-coordinate. That's what we really got to hammer into our brains in this unit, okay? Sine is the y-coordinate, and your y-coordinate is positive here and here. Okay, so where would sine be negative, right? Well, sine would be negative down here and down here, right? That's where sine would be negative because that's where your y-coordinates are negative. So we really want to keep in mind when we think of sine, we're thinking of the y-coordinate. Where's the y-coordinate, positive or negative? All right, like that with cos. Where is cos positive? Well, cos is your x-coordinate. So where are your x-coordinates positive, right? Your x-coordinates are positive here and here, right? So there and there. So that's where cos would be positive, right? There and there. Same thing, where is cos negative, right? Well, cos is negative where your x-coordinates are negative. Where are your x-coordinates negative? On this side, over here and here. So that's where cos would be negative. So it's the same thing. When we think of sine, or at least when I think of sine, I've been doing math for so many years, I instantly think of the y-coordinate. When I see cos, I instantly think of the x-coordinate. And that's what I want to try to get you thinking about, okay? Where are they positive and where are they negative? Now, what about tan? Tan, when I think of tan, I think of slope. Okay, I think about if I were to draw a line through the center of this graph, where would I have a positive slope and a negative slope, right? So let's think about this. When do you have a positive slope? You have a positive slope when the line is going up from left to right. You have a negative slope down left to right. Now I know we covered this in grade 9 because I've taught this for 15 years now in grade 9. So that's something we definitely have to know, right? So look, positive slope. So where are you going to have a positive slope? You're going to have it. Think about that line I'm drawing here, right? Here's that line. Okay, tan is positive here and here. Now, why is that? Think about it. If you're dividing sine by cos, positive divided by positive equals positive, or negative divided by negative equals positive. So tan is positive in the third and the first quadrant. So again, when I do it, I just think of my slope. I draw that line and I think about that. All right, where's tan negative? Well, same thing, right? Tan is negative when the line is going down from left to right. So if we were to draw a line like this, right? This is where tan would be negative. So look, tan's negative here, and tan is negative here. And again, or you can think about it, well, what's a positive divided by negative? Sine divided by cos, sine is positive, cos is negative. What are you going to get? A negative. What do you get when you take a negative divided by a positive? A negative. All right. So that's the most essential thing right there to know when you are answering these questions. Where are sine, cos, and tan positive or negative? Now, why do they call it the cast rule? Because you can spell out C-A-S-T. I didn't invent it. Don't get angry at me, right? Cast. Now, some people are like, well, why don't we start in the first quadrant and go A-S-T-C? Because then I guess it would be the Aztec rule, which doesn't make as much sense, right? So someone just said, well, we'll go C-A-S-T, cast rule, all right? Now, I've never really memorized it that way. I've just memorized it the way I explained it to you. I don't memorize cast. But, so why is it, what does the C-A-S-T stand for? Of course, I'm glazing right over that. All right, here we go. The C, let's start with the A. The A stands for, this is where they are all positive. A for all, okay? So all three of them are positive here. S is for sine. This is where sine is the only one that's positive, right? T is for tan. This is where tan is positive. And C is for cos. This is where cos is the only one that's positive, right? There. That's what it means. Sorry, I almost glazed right over that. So cos, all, sine, and tan. That's what it stands for. It tells you where each one is positive. So some people just memorize that. They do it at the start of the test. They go C-A-S-T, and then they just remember, okay, this is where cos is positive, all are positive, sine is positive, tan is positive. That's the idea, okay? I don't really bother with that though personally, and maybe I think it's more from years of experience. I just think about it the way I explained it to you, where I say I think about where the y coordinates are positive, I think about where the y coordinates are negative, I think of where the x coordinates are positive, negative, I think about where the slope would be positive or negative. Okay. All right, so let's do some examples. All right, I lied. Before we get into examples, I want to first do a kind of quick sketch of where each one is positive or negative. Okay, so you can use the cast rule, think about it that way. Or you can just think about where your y coordinates, x coordinates, and slope are positive or negative. So when we're solving, generally what's going to happen is we're going to be solving and we're going to get two possible points, okay? So let me show you what I mean here, and two possible angles, okay? So what do I mean by that? Well, what I mean is this. All right, so if we have, what's going to happen is we are going to be given a question. I'll just write an example of one. We might get something like find the angle. What is the possible angle? Sine of what angle equals, and you'll just get a number like 0.4 or something like that, okay? What we're going to ask to solve, what we're solving for is theta. What angle gives you, this would be the y coordinate, gives you a y coordinate because that's what sine means, right? What angle gives you a y coordinate of 0.4? So in this case, we're talking about where, again, why are we talking about the y coordinate? Because sine means the y coordinate. That's what this means, right? I'm going to write it right here so we don't forget. Sine is the y coordinate, okay? Where is the y coordinate positive? This is the point. This is like a point on your unit circle. So where would that be? Well, it could be here, somewhere in this quadrant, right? Because that's where your y coordinates are positive. Let's think about it. You have some x coordinate and a positive y. Sorry, I was trying to draw a plus sign there. Or it could be here, right? You have an x coordinate, and this is also where your y coordinate is positive. So there's two possible answers. Your angle could be here, or your angle could be here, okay? So let me just well, I'll leave that for now, okay? So there are two possible answers. Right now, another way some people do is the cast rule. They go, okay, they're all positive here and sine is positive here. But I think about it as terms of the y coordinate. Where's the y coordinate positive? Because that's essentially what sine means. That is exactly what it means. So there's two angles. We measure from standard position, which is starting right here, right? Starting on this line, you have two angles. One of your angles is from here to here. The other angle is from here to here. So there's two possible angles. Now, finding your calculator only is going to give you one of the angles. We have to find the other angle. But the nice thing is, this angle here is the same distance as here. So we can use symmetry and just subtract from 180 to find the second angle. But this drawing I'm drawing is the key thing. Where are we going to be drawing our angles? This is the first thing I do when I answer these questions, is I draw basically this diagram, okay? Now, what about where your y coordinates are negative? Where are your y coordinates negative? Well, if they're positive here and they're positive here in the first and second quadrant, then they're negative down here in the opposite two quadrants, right? This is where your y coordinates are negative, somewhere down here and somewhere down here, right? Now, I'm not being super accurate to where it is. I'm just saying it's down in these quadrants somewhere. So you have some x coordinate and a negative y coordinate, some x coordinate and a negative y coordinate. Now, I don't care what the x is. That's why I'm not putting plus or minus, because we're only focusing when we say sine on the y coordinate. Now, you'll have two possible angles here. You could have an angle that goes from here to here. There would be your first one. We'll call it theta 1. And you could have a second angle all the way around to here. So we'll call that one theta 2. Okay, two possible angles. All right, now, same thing with cos. Cos is your x coordinate, right? Where is your x coordinate positive? Think about this here. Well, my x coordinate is positive. If you like to do the cast rule, it's positive in the all section and the cos section, right? Here and here. The way I like to think about though is I just think about where my x coordinate's positive like this, right? My x coordinates are positive somewhere here and somewhere here in these quadrants, right? So this is where x is positive. I don't really care what y is. So that's why I'm just writing y. I'm just pointing out that that's where your x would be positive. Now, we have two possible angles. One angle from here to here. There's also an angle measured from standard position all the way around to there, and that would be our second angle. And again, when we start doing these, you're going to see the calculator doesn't give us both angles. It only gives us one of them. We got to figure out the other one. Now, what about if we have a negative x coordinate? Well, again, you can do the cast rule. I just think about it's in the opposite quadrants. Where are my x coordinates negative, right? They're over here and here. So I have a negative x coordinate and whatever the heck y is, and a negative x coordinate and whatever y is. You're going to have two angles again. So here's our first angle from there to there, angle 1. Our second angle is from here to here, angle 2. All right, so that's what we do if we're looking for cos. The third option is tan. So you can use your cast rule and think of, and think about, well, where is tan positive, right? You can use the cast rule, and it says they're all positive here and tan is positive down here. But what I do is I just take my ruler or whatever and I draw a line through the middle, and I think, when is my slope positive? That's the thing I'm focused on. When is my slope positive, right? When do I have a positive M, positive slope? All right, so I have a positive slope when the line is going up from left to right. So that means we have a point here and a point here. Right now, remember, why is it positive? Because your x and y coordinates are both positive here. So positive divided by positive is positive, and down here, negative by negative is positive. So don't forget, slope, or tan, right, is the y coordinate divided by the x coordinate, which is sine divided by cos. Okay, so that's where it's positive. Now, what do our two angles look like? Measured from standard position, starting on the x-axis right there. There's angle 1. Angle 2, same thing, starting on the x-axis, brings you around to here. So there's two angles. All right, and to wrap it up here, when is tan negative? When is your slope negative? Your slope is negative when the line is going down from left to right. So this quadrant and this quadrant is where you'll get a negative slope. Now, why is that? Well, over here, the x-coordinate's negative and the y-coordinate's positive. So positive by negative is negative. And over here, the x-coordinate's negative, the y-coordinate's positive. Positive divided by, oops, I did it the wrong way around. I'm losing it, starting to fall asleep. The x-coordinate's positive, the y-coordinate's negative. Negative divided by positive is negative. So our angles, we have one angle from here to here. There's our first angle. Our second angle from there to there. So remember, we start on the x-axis. Right there is where we start. Standard position is what we measure our angles from. Okay? All right, so why am I doing all this doodling beforehand? I'm really trying to set up what we're about to do. So basically, everything we solve today is going to look like one of these 6 diagrams. Okay, so we have to ascertain first, what are they giving us? They're going to give us a coordinate, okay? Either a y-coordinate, an x-coordinate, or the slope, okay? That's what sine, cos, and tan mean. We have to figure out what angles arrive at those coordinates or those slopes, okay? So let's walk through some. All right, so we are going to be solving for the angle, and we're going to use theta, that Greek letter, for all of these, okay? Now, we're going to get questions. Let's look at kind of this first one. I'm going to break it down up here at the top and talk about this. What does this mean? Sine of theta equals 0.5. So remember, what does this mean? This means when I type in sine of an angle, what this means is what angle. What this basically is saying is what angle, okay, has a y-coordinate of 0.5 on the unit circle. That's what this means, okay? So what's the biggest? Do you remember? Think about our unit circle. What's the biggest these numbers can be for sine and cos? The largest they can be is 1, and the smallest they can be is -1, right? Because that's our radius. Remember, our radius is 1. So the farthest you can get from this is like here at 1, 0, or over here at -1, 0, or up here at 0, 1, or down here at 0, -1. That's the largest numbers we're going to get out for sine and cos, would be 1 or -1. So pretty much everything we get here is going to be a decimal number. They're going to be small numbers between -1 and +1. Okay, so when we say sine theta equals 0.5, solve for sine, we are saying what angle, what theta is here, right? What angle, sine of what angle gives me 0.5. So what's the y-coordinate? That's basically what the y-coordinate, is 0.5. What's the angle that ends up at a y-coordinate? Okay, that's what that is. So let's talk about some things. We're going to use our calculators a bunch on this, and hopefully my calculator works out. I downloaded a different one. We'll see how well it works. Drawing a sketch is huge. I can't stress this enough, okay? I find that the people that have the most trouble are the ones that don't draw diagrams for these. They skip through them. They just, and then after a couple days, obviously anything the first couple days you're learning can be tricky, but after doing it day in and day out, the people that find that it's really easy after they've mastered it are the ones who drew diagrams. And the ones who are lost on the test have no idea, they didn't bother doing any diagrams, and probably no homework, right? Draw a sketch, I'm telling you right now, okay? So observe whether the given value is positive or negative. Then you can use the cast rule to figure out which quadrant are they positive or negative in. Okay, I'm going to kind of skim through these details here because you can read them yourself. We're going to determine the secondary angle. I'll show you how to do that. Now, technically, there's infinite solutions, right? Because we can keep going around and around and around, and there's positive solutions and there's negative solutions, right? Because think about it, you could have a positive angle, right? I could be moving this way. I could go 360. I could keep going and going. So there's infinite solutions. We could also go in the negative direction, right? We could go -90 degrees, -180. We could go that way. So we have to cap this off right now because we could end up with infinite solutions. So what we're going to do is I want to just provide the angles. I want to find the two angles that are between 0 and 360. Okay, only positive angles for today. So keep that in mind as we do these, because if we get negative angles, we're going to have to figure out what the positive coterminal angle is. Okay, so I think it's best if we just do some of these and then we can see how it works as we go. So let me move this up and I'm going to zoom in a bit on each one here. All right, so let's check this out. So here's the first one, sine of 0.5, right? Okay, sine of 0.5. Well, what this means, one more time, is this is the y coordinate. Okay, we need to figure out what angle gives me a y coordinate of 0.5. How did I know it's the y coordinate? Because it says sine. Okay, so what do we have to do to isolate theta? We have to take the sine inverse of both sides. If you take the sine inverse of this side, it's gone. We have to do the sine inverse of the other side. Oops, and inverse has that little -1 on it. There we go. Sine inverse of 0.5. All right, so you jump to your calculator. I'm going to pull it up here and see what we can do. All right, so I got this new funky calculator. We'll see if it's any better or worse. I don't know. All right, now this one, instead of saying sine inverse, it says asine, which is short for arc sine. That's another way of saying sine inverse, okay? So it means the same thing. Your calculator probably has the sine with a little -1 above it. So what I'm going to do is type in 0.5, or maybe I have to hit, oh boy, let's see. I'm going to play around with it. All right, let's see. Let's put in, I think with most handheld calculators, you would actually hit the second button, and then you'd have to hit your sine first, and then, because that will give you sine inverse, and then type in the value. I think on this one I actually have to put the 0.5 first, and then I hit second. And it says asine, which again is the same as sine inverse, and it gives me 30. That means 30 degrees. All right, so I got out 30 degrees, right? Now before I even did that, you know what I could have done is we could have figured out where is sine positive. I should have maybe started with that. That's how I'm going to start the rest of them from now on. What quadrants is sine positive in? Sine is my y coordinate, so I know where it's positive. I know it's positive somewhere in this quadrant. I would just draw a little line there, and somewhere in this quadrant, right? You can draw the circle in if you want. I don't have the circle drawn on these, but you can draw the big circle in if you want. Just imagine it's there. Okay, so again, what this means is I'm going to draw this diagram a little more thoroughly. It means, okay, the y coordinate, we don't know the x coordinate right now. We could figure it out, but we don't need it. We just need to know the angle. The y coordinate is 0.5, and there's two places it can be. Now you can just think about the y coordinate like I did, or you can use the cast rule. They're all positive here, and sine is positive here, right? Now notice the calculator spit out 30 degrees. All right, so that would be this angle right here, right? How do I know that? Because 30 degrees is in the first quadrant, right? So angle 1 is 30 degrees, we'll say. All right, so 30 degrees. So I'm going to call that angle 1. All right, I'm going to put a little 1 next to that. There's my first angle. All right, now how are we going to find the second angle? The second angle is from here to here. Just like a mirror, it's symmetrical. Think about it. If this is 30 degrees, I don't know what this little thing is I drew. I think I was trying to draw a degree symbol. All right, if this is 30 degrees from here to here, then from here to here, I know my diagram's not super accurate, is also 30 degrees. Right, so how am I going to find the second angle? Well, if this is 180 right here, right, all we have to do to find angle 2 is go, what's 180? Take away 30 degrees. And we get 150 degrees. So there's my two angles. So at the end, we want to write out our two possible angles. Theta could equal 30 degrees or 150 degrees. All right, now again, the calculator doesn't help you out here. It only gives you one angle. It doesn't give you the second one. That's why I spent, and again, if you're like, well, how do I know all this? How do I know to find it? That's what the whole first 15, 20 minutes of this lesson was. What quadrant? Where are they? Here and here. Draw the diagram. The first angle is right here, obviously, right? There's 30 degrees. The other angle is 30 degrees back from the y-axis right to there, okay? Just like it's symmetrical. How do I know that? Because think about our y-coordinate. Our y-coordinate here, right? If we were to draw a triangle, right, down to the axis here, right, the y-coordinate is the same. It's symmetrical. It's the same distance this way and this way, right? It's 0.5 up, 0.5 up. It's symmetrical. So if this is 30 degrees from here, this is just 30 degrees from here. Okay, now again, it takes drawing a few of these to get the hang of it. Don't panic if like the first one you're like, what? But hopefully you write some of this down and study it. All right, let's check out another one here. Now, before I start doing my calculator work, I'm going to start with what I should have started from, Now again, it says sine of theta equals negative 0.5. Solve for theta. Now to do that, we're going to punch in our calculator. I won't do it yet, but we're going to punch in the sine inverse of negative 0.5, and it's going to give us some angle. Now I can tell you exactly where that angle is going to be before we even punch in the calculator. So let's think about this here, right? This means the y-coordinate. What angle, theta, gives you a y-coordinate of negative 0.5? That is the y. That is the literal y-coordinate. Okay, that's exactly what it is. It's not like a metaphor or a comparison. It's exactly where it is. So where are your y-coordinates? Negative. Okay, your y-coordinate is negative. Well, where do you have negative y-coordinates? You have them in these quadrants. So I'm going to draw a line into these two quadrants, right? That is where my y-coordinate is negative. So some x-coordinate, we don't care. The y-coordinate is negative 0.5. Some x-coordinate, the y-coordinate is negative 0.5. Now, the two angles I can tell you right now we have to find are these two. One from here to here, okay, and another one from here to here. So I know what I need to find before I've even gone to my calculator. All right, so let's pull up our calculator again here, and we're going to do the sine inverse of negative 0.5. So let's clear last answer out. Let's put 0.5 in, put a negative in front of it, and I'm going to do second sine, which is sine inverse, and it gives me negative 30 degrees. All right, so very similar to the last one, but it gave me negative 30. Now, where is negative 30 degrees? Everything we measure starts from right here, okay? So they're giving me this, negative 30 degrees. Okay, that makes sense, right? It ends up where I wanted it to be, right there in that quadrant, right? So you could say negative 30 degrees does give you that point. That's true. What we are looking for, though, are the two positive angles between 0 and 360. So negative 30 is below 0, right? We don't want that in our final answer. Now, the calculator doesn't know that, okay? Now, we'll talk more about the kinds of numbers sine and cos spit out in a little bit. But the calculator doesn't always give you what you want. It just gives you the shortest, sometimes the shortest answer, right? The quickest way to get here, right? Isn't this the fastest way to get there? Is that way, right? It's a lot longer to go in the positive direction. So we need to find what are called the positive coterminal angles, okay? The angles that end at the same spot, that end right here and here, right? But are in the positive direction. Now, just like a mirror, right? If this is 30 degrees from here, guess what? This is 30 degrees from the x-axis there. It's like a mirror. If you flip over from this side to that side, it's the same thing. So let's use that to think about what these two angles are. All right, so let's start with this angle here. I'll highlight them, right? Well, isn't this just 180 degrees plus that 30 right there, right? Half a circle plus 30. So my first angle, we'll call it angle 1, is going to be 180 plus 30. Now, how did I know that? Because look, here's a half circle, 180 plus the 30 more. So it's 210 degrees. There's one of my angles. The second angle, how can I find that? Well, if you think about it, we've come all the way around from here to here, right? 30 more degrees will get us to 360, right? Because I got that 30 labeled there. So all I got to do is take 360, a full circle, and minus 30. So it helps a lot to draw the diagram, because if you don't have the diagram drawn, especially when you're starting out, you're going to get really lost on these, okay? I mean, I've been doing this for years, teaching it for 15 years, and I went to university and high school just like you, and I still draw the pictures, right? It really helps make sense of this stuff. So my two angles are 210 and 330. Now, again, if you're asking why couldn't we just make negative 30 degrees one of the angles, negative 30 is a correct answer if we're going to allow any angle to get to there, right? We could even go from here to here. Well, this would be negative what? This is 180 minus 30, so this would be negative 150 degrees if we did in the negative direction, right? But we don't want the negatives. We want starting here, moving in the positive direction, and I only want you to give me the angles between 0 and 360, okay? So those are the two answers we're looking for, 0 to 360. All right, let's do some more here. Okay, now we're dealing with cos. We did two with sine, a positive sign and a negative sign. So now we're dealing with cos. So remember, what does cos mean? It means the x-coordinate, right? What x-coordinate gives you this angle? So we need to figure out the angle when the x-coordinate is 0.5. So we have a positive x-coordinate, right? The x-coordinate, then that's what 0.5 is. The x-coordinate on the unit circle is positive, right? So what I think of, instead of the cast rule, you can totally use it though. Cast rule says they're all positive here and cos is positive down here, right? The way I do it is I just go, where are my x-coordinates positive? Same thing, x-coordinates are positive in this quadrant and x-coordinates are positive in this quadrant, okay? So again, the cast rule is just a way to think about what you already know, right? So we have 0.5 and 0.5. There's where my x-coordinates are positive, right? So again, I don't have the circles drawn in on these. Maybe it would have been better if I did. These are really sloppy, but you can think about, there's the unit circle, right? What are the x-coordinates on the unit circle? We're still using the unit circle, okay? All right, so here we go. So now that I've figured out what quadrants they're in, I already know what my angles are going to be. I can tell you right now. One of them is going to be from here to here, and I tell you right now, that's the one the calculator is going to spit out. It basically gives us the shortest, quickest one. It's going to tell us that first angle there. But we have to figure out the second angle. Now, like a mirror, this is the same here. So like if it gives us, 30 or 20 or something, it's going to be a different number. But let's say it gave us 25, right? Then this would be like negative 25. It's the same thing. It's 25 degrees away from the x-axis, okay? Now, the other angle then we can find by just going around here and subtracting that angle from 360, okay? All right, so let's punch in our calculator. We go, all right, theta equals, we got to do the cos inverse of both sides. So cos inverse of 0.5. I'll save you the time of watching me punch in the calculator because I know it's going to be exactly, this is one of our special key unit circle ones. It's going to be exactly 60. All right, so the 60 is this one right here, which should make sense, right? And people say, well, how do you know that? Because 60 degrees is in the first quadrant, right? This is where 90 degrees is, right? This is where 180 is, right? This is where 270 is. This is where 360 is. All right, so 60 degrees. It should match where we drew our line. It does. So we are good. So our first angle, great, we got it. The second angle we have to figure out is the one that I drew going all the way around from here to here, right? Remember, if this is 60 degrees this way, this is 60 degrees this way, right? It's the same thing, right? It's symmetrical, okay? So all I got to do to figure that one out is subtract 60 from 360. All right, so let's go, what's 360? Minus 60, and we're going to get 300 degrees. And there's your two angles. So let's write them out. So our final answer, theta is equal to 60 degrees or 300 degrees. Now again, it wouldn't be wrong to say 60 degrees or negative 60 degrees, right? But again, we only want the positive answers between 0 and 360. So that's why I'm not using negative 60 instead. That would be shorter. That would be the quicker answer. Just say negative 60, right? But we only want to find the positive ones, okay? So two positive angles that, all right, yeah, let's move on to the next one. All right, now we got cos of a negative. Now let's think about this here. Think about your unit circle for a second, right? Let me just draw like a tiny little unit circle here. All right, where is your x-coordinate -1? Think about that. There's only one place where your x-coordinate's -1 on this circle, right? It's right here, right? You have a -1 for the x, 0 for the y. So watch what happens when I do cos inverse here. Now, again, let's think about our cast rule really quickly too. Now, it only gets tricky when you get ones that land right on the axis. That's where the cast rule kind of falls apart. So where is cos positive, right? Well, they're all positive here. Sine is positive here. Tan is positive here. Cos is positive here, right? So that means cos is negative here and here because this is where it's positive in the all and C section. So it's over here somewhere, right on this half. Well, watch what happens when we punch in. Well, I won't even say watch what happens. You just trust me. I don't want to bore you by hitting the calculator buttons. If you do cos inverse of -1, you will get out exactly 180 degrees. So the only time the cast rule kind of falls apart is when it lands on the axis because 180 degrees is right here, right? That is where you are going to get, right, the x-coordinate to be -1. And now the y-coordinate 0, but we don't really care about that, so I'm just going to write y there because I don't care. I want to stay focused on the coordinate at hand. So in this case, there's only one positive answer, right? There's only one positive answer. Now you might be thinking, well, there's other ways again. They're going to negative, right? There's only one positive answer between 0 and 360. We got to be clear about that too because there's infinite answers technically for all of these, okay? So let's just be clear between 0 and 360, okay? Okay, so when you land on the axes, that's where we hit the interesting ones, okay? Which is generally, when you land here or here or here or here when you're getting things, that's when you're, when x or y are positive or -1 or where x or y are 0, okay? That's when you get these answers where you don't get two answers sometimes, right? Now 0 you can get couple, but when it's +1 or -1, you can only get one possible answer. So we'll see as we do a few more of these and as you do the homework what I mean. That's where the drawing helps, okay? 180 degrees, you draw, then you realize, oh, there's only one way to get there. Now, could we say that, let me just draw, and here's like positive 180 degrees, right? That's my angle going that way. Could we say negative 180 would land you at the same place? Yes, if we would include negative angles, right? You could also get there that way, but we're not going to include that. Could we also, because we could do this all day, right? We could also go, what if I go 360 plus another 180? Would that land me there? Yes. Or what if I went the other way, right? So again, that's why we have to limit this. So most of the ones you're doing, not all of them, will end up with two solutions. But if you land on the axis, you may have only one solution, okay? So just keep that in mind. So that's it. We only have one answer. So our final answer, if this were a test or something, generally what I do on a test is I have you guys just kind of fill them out a box at the end. There's your final answer. All right, let's do another one. All right, now we've done 2 sine, we've done 2 cos. Let's do a couple of tans. Now, remember, what does tan mean? Tan means the slope. And we need to focus on the fact that the slope, all I really care about is that you have a positive slope. So tan means my slope, and my slope is positive. So the first thing I do is I get out my ruler, see if this will work, and I draw a line. I know some of these I haven't been using a ruler. A positive slope looks like this, going through 0, 0, right? And again, I don't have my unit circle drawn. Probably would have been a good idea for these on these graphs, but you get the idea, I think. All right, so that is where we have a positive slope, there and there, right? Or that line. So we're going to hit a point somewhere in this quadrant and a point somewhere in this quadrant, right? Now, if you like to use the cast rule, where is tan positive? In the all section, and the T for tan section, right? So that's what the cast rule is, just a way of memorizing something we already know. When do we have a positive slope? When it's going up from left to right. All right, now, I can tell you right now, the calculator is going to spit out one of the 2 angles. It's going to give us this angle. It's going to give us the shortest distance angle, but then we have to figure out the other angle here. Now, how are we going to do that? Well, the distance here, let's say that this is 30 again. I'm just going to make it up. Then this is also 30. It's symmetrical, right? The distance from the x-axis measured to our angle, from the x-axis measured to the angle, is the same. So whatever the calculator gives us for here, all I have to do is add that to 180 to find the angle from here, because this is 180 plus that, okay? So let's see what we get. So I'm going to punch in my calculator theta, and I have to hit tan inverse, and make sure you hit the inverse button. I can't tell you how many times in my life I don't hit the inverse, and I keep getting weird numbers, and it takes me like 2 or 3 minutes to realize what a dummy I've been. I've been doing this my whole life, like still while teaching. I'm like, why am I not? I keep forgetting the inverse. I always just get tan. I don't know. It's just brain freeze. I've had this my whole life. All right. So you punch it in, and we're going to get approximately 66.8 degrees. So this angle right here is 66.8 degrees approximately, okay? So we're going to get decimals. Don't be surprised you get decimals for some of these, which means from here to here is also 66.8. So to find the second angle from here all the way to here, we just need, there's angle 1. Angle 2 is going to be approximately 180 plus 66.8. So if we add those 2 together, you're going to get approximately 246.8 degrees. And that's literally all there is to it, okay? Now again, you got to know where they are first. The drawing is key. It's essential, okay? And I mean, I don't know. I was in high school once too. I was lazy, so I get it. But if you want to get good at this stuff, I'm not trying to give you busy work, although a lot of times it is keeping you busy. But this is some really key important stuff to practice, and being able to draw the diagram and really understand this going into grade 12 is really important. It's not just about getting these numbers, because a lot of people are like, well, I got the numbers, but where are they? Because as we get into bigger problems, we need to identify more about what quadrant they're in, okay? So drawing the diagram is part of your answer. It's part of your solution, showing that you recognize where these coordinates occur, okay? And where these slopes are. All right, let's do one final one for this first lesson. All right, final one. Again, tan means the slope, and it's a negative value. So this is the slope. This is literally the slope, okay, of a line, and it's negative, okay? So slope is negative of a line going through 0, 0 that hits our unit circle, okay? Oops, at 2 spots. So if we were to draw, a line through here and it hits our unit circle, okay, it's going to hit in these 2 quadrants. Now again, you could use the cast rule. How does it work here? They're all positive here, and tan is positive here, so that means it's negative in the opposite two quadrants, right? I just draw the line. I think about my slope being negative, though, and do it that way. So we are going to get 2 values. We need to figure out this one and this one. Now, what's the calculator going to give us? It always basically spits out the closest one. It's going to give us this, and we're going to have to figure out what the positive equivalent of that going the other direction, right, from here to here and from here to here. So let's see what the calculator gives us. So if you punch in your calculator, theta equals the tan inverse of negative 0.56, okay, we end up getting negative 29.2 degrees approximately. Now that is right here, moving, starting in standard position, right there on our x-axis, negative 29.2 would be there. Now, that's not an acceptable answer because we want the positive ones. Now, the good news is this is also 29.2 on the opposite side, right? It's symmetrical, okay, away from the x-axis. So to find our two angles, to find our first one from here to here, notice how it makes a half circle? So to find our first angle, we just go, well, what's 180 minus 29.2, right? And we get our approximate answer of approximately 150.8 degrees. So that's our first angle, right? 50.8 approximately. All right, now to find our second angle, we want the positive one that goes all the way around and meets up here. Now, again, that's 29.2 back from 360, right? So all I got to do is go, what's 360? And again, how am I figuring this out? By looking at the diagram, okay? So 360 minus 29.2, and approximately, what are we going to get? 330.8. All right, so there's your two angles. This would be 330.8. All right, so today's homework is essentially you are going to be solving these same types of questions. You're going to be given questions that look exactly like this. Draw yourself a little sketch, okay, and then do the inverse, right? Sorry, I'm going to just write these in here. So do the same thing, okay? So everything you're given, whatever you're given, do the inverse of that. Draw yourself a little diagram. Before you even find the inverse, what quadrant is it? Draw your little diagram and then go from there and figure out your two angles. And don't be afraid to ask questions online, okay? Thanks.